In this video, we're going to continue talking about chemical equations and go through another example together. So we're going to talk about our writing and balancing chemical equations, section 8.2. In this question, we're looking at the balance equation for the reaction of silver nitrate with hydrogen sulfide to produce silver sulfide and nitric acid. So I've already placed the word equation here. Silver nitrate plus hydrogen sulfide yields silver sulfide and nitric acid. So in this first part, we need to make sure we're getting the correct formula. So we have silver nitrate, hydrogen sulfide, silver sulfide, and nitric acid. And you can double check these formulas, but these are all correct. So make sure you can understand why these formulas are written this way. If we do a quick tally, we can see that we have one silver, two hydrogens, one sulfur, one nitrate on our reactant side. On our product side, we have two silvers, one hydrogen, one sulfur, and one nitrate. So we know we're going to have to change our silvers and our hydrogens at least, and that actually will also change our sulfur and nitrates at some point. So let's try in balancing, looking at adding a 2 to our silver nitrate. So we have a 2 here, which means we're going to have a 2 on our nitrate side. Now we've balanced our silver, but we are unbalanced with our nitrate. You can sort of, as you pick up on these, you can sort of see that we have our H2S on our reactant side and our HNO3 on our product side. We're going to need to have two H's. We're going to have two nitrate groups. This actually will work out pretty easy. So here we now have a coefficient in front of our nitrate group. So we have 2 HNO3. We can now do a final tally to make sure all of our atoms are balanced. And so as you learn how to do these, as you practice more, you'll start to see some patterns and they'll get easier. But balancing equations is very important. And so a lot of practice needs to take place. And we'll work on some in lecture. In addition, this video, we're going to talk about all the information we're getting from a chemical equation. And so we've started to see our coefficients. So in here we have propane plus 5O2 yields 3 carbon dioxides and 4 water molecules. So we can say here that they are in molecules. We also can use these coefficients as moles. So if we look at this question, from the chemical equation below, how many moles of HF can be produced from 2 moles of hydrogen gas? When we look at our coefficients, we know that if we don't see one, that's going to be 1. So we have a 1 mole of hydrogen gas plus 1 mole of fluorine gas, which gives us 2 molecules of hydrofluoric acid, okay, or hydrogen fluoride in case of a gas. So for every 1 mole of hydrogen, 2 moles can be produced. If we have 2 moles of hydrogen, you can then produce 4 moles of hydrogen fluoride. So in this example, we're going to practice the same thing, so pause the video now. So from this chemical equation, we're looking at again at propane plus our 5 molecules of oxygen yields 3 molecules of carbon dioxide plus 4 molecules of water. So if we have 2 molecules of propane, how many moles of oxygen or how many molecules of oxygen are we going to need to burn? We're going to double everything, right? So if we have 2 moles of C3H8 with 5 moles, we're going to need to double them up. So for every 1 molecule of propane, we now need 5 molecules to fully react. And this is going to continue where chapter 9 takes off looking at this.